Hello students, today we are going to solve few problems on clocks and calendars. These problems are very important from the board examination point of view. Please visit our website www.examsnet.com to practice such questions. You can also download our app. The link is given in the description box. Let's begin with question number 1, right? How many times in 12 hours the hands of a clock are at right angles? Students, in a clock, every hour the minute and hour hands of the clock form two right angles, right? For example, so we'll consider, right, 12 o'clock, right? 12 to 1. So between 12 to 1, so at 12:15 or nearly 12:20, so at this time there forms a right a right angle, right? And also when the time is nearer to 12:40 to 50, right? So at this time also a right angle is formed, right? So every hour the minute and our hands of a clock form two right angles, right? So we'll consider from 12 to 12, 12 midnight to 12 noon, right? Between these two, so in 12-hour duration, so how many times right angles will be formed, right? So in a clock, so from 12 to 1, right, two times right angles will be formed, right? So from 1 to 2 also two times right angles will be formed, right? But between 2 and 4, 2 and 4, so there are only three right angles, right? So three times between 2 and 4, right? When the time is somewhere 220, right? 220 to 225, a right angle is formed, right? When the time is 3 o'clock, right? When the time is 3, a right angle is formed. When it is 3, nearly 340, not exactly 340, 335 at 340, then a right angle will be formed, right? Then after 4 o'clock, right? So between 2 and 4, three times right angles will be formed, right? And 4 to 5, two times right angles will be formed, right? And 5 to 6 also, two times. And 6 to 7, again, two times right angles will be formed, right? And 7 to 8 also two times, right? Similarly, but when the time is 8, so 8 to 10 in 2-hour duration, only three times right angles will be formed, right? So similarly, in the case of 2 to 4, right, three times right angles will be formed. When the time is 8 o'clock, right, between 8 and 10, so 8 will be somewhere here, 9 will be here. So here 8 to 10 means when the time is nearly 8:20 or 8:25, so at this time a right angle is formed, right? Then directly when it is 9 o'clock, a right angle is formed. When the time is 9:40 or something, right? So in this time a right angle is formed. Totally three times between 8 and 10 right angles are formed, right? And after that 10 to 11, right? Two times right angles will be formed, right? So here total it is 2 plus 2 4 plus 3 7 plus 2 9 plus 2 11 plus 2 13, then 15, 18, 20, and here we are taking 12 to 12, right? So 11 to 12, so again two times. Totally it is 22 times, right? In 12 hours, right? Therefore, so come back to the question. How many times in 12 hours the hands of a clock are at right angles? So hands of a clock are at right angles. So 22 times in 12 hours, right? So in a day, 44 times, right? So in 12 hours, 22 times the hands of a clock are at right angles. Hence option D is the right answer. Question number 2. The minute hand of a big wall clock is 35 centimeter long. Taking pi as 22/7, the length of the arc its extremity moves in 18 seconds is. So students, will consider a wall clock, right? And a minute hand will consider. Anywhere you can consider the minute hand. And its length is given as 35 centimeter. This is minute hand. Minute hand. So here we need to consider length of the arc when the second hand moves in 18 seconds is. So we'll consider the second hand with dotted line. So at 18th second, it will be somewhere here, right? Second hand, and the time is 18 seconds, right? Here in 18 seconds, so the minute hand also moves by some degree, right? So somewhere here it will be. Somewhere here it will be. Minute hand also moves to some degree, right? So there it forms an arc. This small portion AB, right, is an arc. We need to find AB, which is length of the arc. Length of the arc formed by the movement of the minute hand, right? For that, we need the angle formed by the minute hand here, right? So in 18 seconds, so when the second hand moves 18 second, in 18 second, so how much distance it covered, that gives the length of the arc. So what degree the minute hand, to what degree it is moved, that we need to find, which let it be theta, right? So here students, so in 60 seconds or in one complete rotation of the second hand, minute hand moves by 6 degree, right? So we'll consider in 1 minute, particularly 1 minute is nothing but one complete rotation of a second hand, right? In 1 minute, so minute hand moves by 6 degree. Moves by 6 degree. That means 1 minute means in 60 seconds, it moves 6 degree. Therefore, in 18 seconds of the second hand, right? Therefore, in 18 seconds, we'll mention. In 18 seconds, minute hand moves by, so 60 seconds, it moves by 6 degree. Therefore, in 18 seconds. Very simple calculation. It moves by 1.8 degree. Here, theta, it is equal to, so formed at the center is 1.8 degree. Right? Why do we need theta? To find the length of the arc. Right? So by the formula, length of the arc is equal to length of the arc. Arc is nothing but it is a portion of the circumference. Right? Here, circumference formula is 2 pi r. But it is a portion of the circumference. Therefore, 2 pi r into theta by 360 gives length of the arc. So, general formula says, here theta is 1.8 degree. So, we'll simplify it. 1.8 degree by 360 degree into 2 into pi is 22 by 7. R is radius of the circle, which is nothing but length of the minute hand. So, which is R, right? R is length of the minute hand. We'll mention it. R is length of the minute hand, which is 35 centimeter. So we'll write the value of R, right? Simplify it, you'll get the length of the arc. So here 7 into 5 is 35. So 5 into 10 into 22, 220 into, so instead of 1.8, I'll write 18 by 3600, right? Just I want to remove the decimal point, right? So shift the decimal point to one place, right? So 18 into 200. So I have 220 by 200, which is nothing but 22 by 20, which is nothing but 1.1 centimeter, right? The length is in terms of centimeter. So length of the arc is 1.1 centimeter. Hence option B is the right answer. Students, to find length of the arc, first we need to find the angle made by the minute hand in 18 seconds. In 18 seconds, it makes 1.8 degree angle, right? Because in complete 60 seconds, it makes 6 degree angles, right? So if if the minute hand is at 12, so in one complete minute, it moves by 6 degree. It will be somewhere here, so that the angle formed between its initial position and final position will be 6 degree in one complete minute, that is in 60 seconds, right? Therefore, in 18 seconds, so it forms 1.8 degree, right? Therefore, length of the arc. So after calculation, so we have got 1.1 centimeter as length of the arc, right? Option B is the right answer. Question number 3. If January 1, 2006 was Monday, then find on which day of the week year ends. So here, students, January 1, 2006 was Monday. Here, 2006 is not a leap year. It is not a leap year, right? That means the number of days in the year 2006 are 365. There are 365 days in a year. Since it is not a leap year, so number of days in 2006 is equal to 365 days, right? So we'll find how many weeks are there in 365 days, right? Therefore, in 365 days, so 365 by 7, so which is equal to 52 weeks and 1 day. In a year, there are 52 weeks and 1 day, right? Here, the first day is Monday, right? Therefore, the last day in a week will be Sunday, right? So, in the 52nd week, last day is Sunday, and the year has one more day, 52 weeks and 1 day, right? Therefore, the last day is again Monday. Therefore, the year ends with the same day, right? So on Monday of the week, 2006 ends, right? Because first day is Monday, right? First day is Monday. So last day of 52nd week, 52nd week is Sunday, right? Last day of any week here in this year is Sunday, and the year has one more day, right? 52 weeks and 1 day, right? Therefore, last day is Monday, right? Therefore, option C is the right answer. So, the year ends on the same day, which is Monday, right? Option C is the right answer. Question number 4. What will be the angle between the two hands of a clock when it is 3 o'clock? Very easy question. So we'll consider a clock and the time is 3 o'clock, right? Here, our hand is on 3. Our hand is on 3 and minute hand is on 12, right? So the angle between two hands is 90 degree, right? Hence option C is the right answer. So another method is, so in a clock, we are considering how many divisions here. In a clock, we can divide the portions in a clock into 60 parts, right? Here, between 12 and 1, there are 5 equal parts, 5 parts. Each part is considered as 1 minute, right? So 1 minute. So here, 1 is considered as 5 minutes, 2 is considered as 10 minutes, 3 is considered as 15 minutes, right? So out of 60 parts, we are considering 15 parts. From 12 to 3, there are 15 parts, right? Therefore, the angle between 12 and 3 is, right? So very easy. So out of 60 parts, we are considering 50. Therefore, out of 360 degree, because angle at the center is 360 degree, right? Out of 360 degree, what degree is the part 12 to 3? Very simple. So 15 into 4 is 60, 4 into 9. So angle between 12 and 3 is 90 degrees, right? Therefore, option C is the right answer. One is simply by looking at the hands, our hand and minute hand, and so that you can predict, right? So what is the angle between the respective hands, right? Or you can consider two hands generally. So if it is 12 and 1, so angle between 12 and 1 is angle between any two numbers in a clock is equal to 30 degree. Here 3 o'clock means angle between 3 and 12. So there are three divisions here. So 30 plus 30 plus 30, totally it becomes 90. This can also be taken, right? So here option C is the right answer. Question number 5. Given that 5th July 1981 was a Sunday, what was the day on 5th April of the same year? So students, in the year 1981, we are considering the months April, May, June and July, right? And in the month of April, we are considering the days from 5th of April. Since there are 30 days in the month of April, so from 5th to 30 means we are considering 26 days in the month of April. Whereas in the month of May, we are considering all the days, 31 days. And in the month of June, we are considering all the days, 30 days. And in the month of July, up to 5th July, we are considering, right? So 5 days we are considering. Therefore, totally it becomes 92 days. In 92 days, sort of 92 days, the last day is 5th July, right? Which is a Sunday, right? So, last day is a Sunday. So, before that, how many weeks are there in 92 days, right? So, number of weeks is equal to 92 by 7. So 7 into 1, 7 into 3. So there are 13 weeks and 1 day. Right? So this 1 day, last day is 5th July, which is Sunday. Right? So the last 1 day is 5th July, which is Sunday. Its previous day is Saturday. Saturday is last day of the 13th week, right? Last day of 13th week. And it's the first day. First day of every week is Sunday. Right? So here in 13 weeks, first day of the week is Sunday and the week ends with Saturday. Again, Sunday repeats. Therefore, last day, right, which is 5th July is Sunday, which is already given. We are considering in the reverse manner. Therefore, first day, right, so the day which we are considering, so which is 5th April was again Sunday. Right, was again Sunday, right? Here we have considered 5th July and the respective date is Sunday. 5th July is Sunday and its previous date is 4th July, which is last day of 13th week, right? And first day of the 13th week is Sunday. And its previous week, so 12th week's first day is also Sunday. 11th week's first day is also Sunday. 10th week, first day is also Sunday, like that. First week's first day is also Sunday. Therefore, first week's first day is which day? It is 5th April, right? Which is also Sunday. Option D is the right answer. Question number 6. How many times in a day the hands of the clock are straight? Students, hands of the clock are straight means the hands can be coincide or they can be in opposite directions. For example, so coincide means hands can be coincide means so they make 0-degree angle, right? 0-degree angle. So that means so at 12 noon, right? So the hands coincide, right? Therefore, they make 0-degree angle in opposite direction. If hands are in opposite direction, they are making 180-degree angle, right? 180-degree angle. For example, at 12:30, right? So the hands make 180-degree angle. Therefore, how many times in a day? In 24 hours. So how many times in a day hands of the clock are straight? So students, the clock's hands coincide with each other in 24 hours. So they can coincide with each other 22 times, right? So in 24 hours, right? So they coincide with each other, how many times? 22 times. Coincide means at 12 noon, then when it is 1 5, right? So like that. So totally 22 times the hands can coincide with each other, and also in 24 hours, so that the hands can be in opposite direction 22 times, right? Therefore, hands are in opposite direction. How many times hands can be in opposite direction? 22 times, right? For example, 12:30, then 1:35, somewhere in between 1 o'clock and 2 o'clock. So somewhere here 1 and 35, or in between 1 and 2 and 35 to 40, they make straight angle like that. So when it is 2:45, not 2:45, when it is 3:45, right? 3:45, when it is near 4 o'clock, when it is 6, right? 6 o'clock. So in all these cases, hands can make 180-degree angle, right? So hands can be in opposite directions, right? So such that in 24 hours, so 22 times the hands will be in opposite directions, right? Therefore, totally the hands of the clock are straight. How many times? Totally it is 22 plus 22, 44 times the hands of the clock are straight, right? In a day, in 24 hours, right? In a day. If the question is, like if it is in a day, the hands of the clocks are coincide how many times, right? So it will be 22 times. If the clocks are straight, if the question is like this, so these clocks can be coincide with each other or opposite in directions. So both the ways you have to consider, and totally it is 44 times the hands of the clock are straight. Option C is the right answer. Question number 7. The minute hand of a clock is 28 centimeter long. If it moves between 8 a.m. and 8:45 a.m., what is the area covered by it on the face of the clock? So here, when it is 8 a.m., when the time is 8 a.m., the minute hand will be exactly on 12. Right? Here, it is 8 a.m. So our hand will be on 8, minute hand will be on 12, right? So when it covered 8 a.m. to 8:45 a.m. So when it is 8:45, so it will be on 9, on the number 9. So what is the angle between 12 and 9? What is the angle covered by minute hand? This is minute hand, the longest hand here, right? So it covered 270-degree angle, right? Here when it is on 6, so the angle is 180 plus 90 becomes a 270-degree angle. Therefore, theta, so angle covered by minute hand, theta is equal to 270-degree. Right, between 8 a.m. and 8:45 a.m., it covers 270-degree angle. Here we need the area covered by the minute hand on the face of the clock. That means this area, right? So the shaded part which I am showing here. So the area we need to find, this area. Right? For that, students, we are using the formula of area of the sector, right? So area of the sector, area covered by the minute hand on the face of the clock means area of the sector of a circle, right? This is a sector of a circle. So by the formula, it is pi r square into theta by 360. So here pi r square is whole area of the circle, right? Here the sector is a portion of the area of a circle, right? It is a small portion of the area of a circle. Therefore, so this portion, in this portion, so there is an angle at the center, right? Therefore, it is theta by 360. So now pi is 22 by 7. Radius is nothing but minute hand, right? Length of the minute hand is 28 centimeter, right? Therefore, here r is equal to 28 centimeter. So r square becomes 28 into 28 into theta is angle covered by the minute hand, which is 270 degree by 360 degree. Simplify it. So 7 into 4 is 28. Here 0, 0 will get cancelled. So 9 into 3, 9 into 4 is 36 here. And 4 and 4 will get cancelled. So we have 22 into 3, which is 66, right? Into 28, right? Simplify it. 66 into 28 becomes, so 8 into 6, 48. 48 plus 4, which is 52. Again, 6 into 2, 12, then it is 13. So we have 1848 centimeters square is, so area of the sector. So area covered by the minute hand between 8 a.m. and 8:45 a.m. So 1000, how much? 1848 centimeters square. Option B is the right answer. Question number 8. By how many degrees the angle formed by our hand and the minute hand changes when the time changes from 5:20 a.m. to 5:22 a.m. So here students, at 5:20 a.m., what is the angle between our hand and the minute hand, right? So we'll consider at 5:20 a.m. angle between minute hand and our hand. So we'll consider a clock, right? So this is 12, 3, 6, and 9. So 5:20 means, so our hand comes somewhere here, right? 5 and the 20 minute hand comes here on 4, right? So the angle formed between minute hand and our hand. So this angle. So we'll consider angle formed. Angle formed between minute hand and our hand is equal to, so here students just imagine it is 5 o'clock, right? So the minute hand changes from 12 to 4, that is in 20 seconds, sorry, in 20 minutes, in 20 minutes, this our hand also changes its position to somewhere here in 20 minutes, right? So in 1 minute, our hand changes by half degree, right? We'll mention it. In 1 minute, our hand changes by half degree. Therefore, at 5:20 a.m. means in 20 minutes, right? Therefore, in 20 minutes, our hand changes by how many degrees? So in 20 minutes means 20 minutes by half. So by 10 degree. Therefore, so the degree or the angle formed between its initial position and the final position from 5 to its next position is 10 degree. This is with respect to our hand, right? Which is 10 degree plus. So what about the position of minute hand, right? At 5:20. So here minute hand is here at 4. Angle between the original position of 5 or the hour hand, 5 and 4. What is the angle between two consecutive numbers on a clock? It is 30 degree, right? Therefore, 10 degree plus 30 degree. So, we'll consider angle between 4 and 5. That is 20 minutes and 5, right? Is equal to 30 degree. Therefore, at 5:20 a.m., angle formed between minute hand, which is at 4, and hour hand is not exactly on 5, which is slightly deviated from 5, right? Therefore, it is 30 degree plus 10 degree. So, totally it is 40 degree. So, hour hand and minute hand, they make an angle of 40 degree when it is 5:20 a.m. Now, we'll consider at 5:22 a.m. Now, at 5:22 a.m. So again, we'll consider a clock. So 12, 3, 6, and 9. Right? At 5:22, so that means 22 comes close to 4, not very close to 5. Right? Here, minute hand, so it comes close to 4. Right? Since there are 5 divisions between 5 and 4, right? So total angle between 5 and 4 is 30 degree. We all know that. Whereas the hour hand, so at 5:22 a.m., it will be here, the shortest hand, right? Therefore, at 5:22 a.m., right? So that means in 22 minutes, what is the angle formed by our hand? Right? In 1 minute, we all know that. So our hand changes by half degree, right? Therefore, in 22 minutes, our hand changes its position by how many degree? Its initial position when it is 5 o'clock, it is on 5, right? But in 22 minutes, our hand changes by 22 by 2, which is 11 degree, right? Therefore, the difference between its initial position, which is on 5, and its final position is theta, which is 11 degree, right? Now, the angle between 22nd minute and 5 o'clock, right? And 5. So, angle between 22nd minute or 22nd minute hand and 5, right? So this position, right, which I am showing, this position is equal to, since there are 5 equal divisions between 5 and 4, and angle between 5 and 4 is 30 degree, right? 30 degree by 5 is equal to 6. So each division is 6 degree. Each division between 5 and 4 is 6 degree. You can mention each division between 5 and 4 is equal to 6 degree. So that 6 into 5 becomes 30 degree. So angle between 5 and 4 is 30 degree. But between 5 and the minute hand at 22nd minute, right? So there are 3 divisions. Therefore, 3 divisions is equal to 6 into 3, 18 degree, right? Therefore, angle between 22nd minute hand, right, which is very close to 4, not exactly on the floor, and 5. So, the angle between them is 18 degree. Therefore, so total angle formed between minute hand and hour hand. Minute hand and hour hand at 5:22 a.m. It is equal to, so between minute hand and 5 o'clock it is 18 degree, plus between hour hand and the original 5 it is 11 degree. Totally it is 29 degree, right? At 5:22 a.m. angle between minute hand and hour hand is 29 degree, right? So here the question is, So by how many degrees angle formed by minute hand and hour hand changes? By how many degrees the angle changes from 5:20 to 5:22 a.m. So here at 5:20 the angle formed is 40 degree. It is not 30 degree. It is 40 degree, right? Whereas in 5 at 5:22 it is 29 degree. Therefore, angle changes from 40 degree to 29 degree, right? So by how many degrees it changes? 40 minus 29 by 11 degree, changes by 11 degree, right? Therefore, look at the options. Here, there is a small correction. So instead of 1 degree, it should be 11 degree, right? Option A should be 11 degree. Option A is the right answer, right? So it was a 40 degree at 5:20 a.m. And when it is at 5:22, so it becomes 29 degree angle between minute hand and hour hand, right? So when it is 5:20, it is 40 degree and it will decrease, right? So 29 to, so it comes to 0 degree when it is, so when it is 5:25, 26, not exactly 26, when it is 5:27, right? So when the time is like that, it comes to 0 degree also, right? Therefore, the change in the degrees is 11 degree. Option A is the right answer. Question number 9. What was the day on 1st January 1 AD? 1 AD means 1 Anno Domini, right? 1 Anno Domini. So here the Anno Domini system was invented in the year AD 525 by a monk in the Roman Empire. So it was invented in the year AD Anno Domini 525. So by a monk in the Roman Empire. The Roman natural system, which was still in use at the time, has no concept of zero, right? Therefore, the day after 31st December 1 BC, so before 1 Anno Domini, it was BC, it was 1 BC, right? So before that, it was 2 BC before Christ, right? It was 3 BC, like that. So after 31st December 1 BC, so the day was named as 1st January AD, Anno Domini. So it was on Monday. 1st January Anno Domini was on Monday, right? Before that, it was 31st December, which was on Saturday, right? So next day of 31st December 1 BC was named as Anno Domini Day, right? 1st January Anno Domini. It was on Monday, right? Option B is the right answer. Question number 10. A wall clock gains 2 minutes in 12 hours, while a table clock loses 2 minutes in every 36 hours. Both are set right at 12 noon on Tuesday. The correct time when both show the same time next would be. So here students will consider the wall clock. It was set, right? So it loses 2 minutes in 12 hours, right? So the wall clock was set at 12 noon, right? So at 12 noon, and a table clock, right? So wall clock gains 2 minutes, in 12 hours, right? Therefore, in one day, how many minutes it loses? Sorry, it gains. So in one day, it gains 4 minutes. In 12 hours, if it gains 2 minutes, in one day, it gains 4 minutes, right? So come to table clock. So it loses 2 minutes. So it loses 2 minutes in 36 hours. Therefore, in 24 hours, so it loses. So in 36 hours, if it loses 2 minutes, in 24 hours, right, it loses. So 12 into 2, 12 into 3. So 4 by 3 minutes, it loses. It loses 4 by 3 minutes, right? So according to the options, so here, so after 130 days, after 135, again, after 130 days at 130 night, and after 1:35 at 12 midnight, right? So here the question is the correct time when both show the same time next would be. So here wall clock was set at 12 noon, right? And also the table clock, right? So in order to meet to the same point, to the same time once again, so the minute hands of both the clocks should complete one rotation, right? At least they should complete one rotation, right? So to meet once again, the minimum minutes to lose or gain should be one complete rotation of minute hand should be 60 minutes, right? Here the wall clock should at least gain 60 minutes of time, right? And table clock also should lose at least 60 minutes of time, so that the minute hand should come back to the same position, which is at 12, right? Therefore, in how many days these hands will come to the original position at 12, right? Therefore, we'll consider 130 days. So consider the case of wall clock, right? So if it gains 4 minutes in one day, so in 130 days, right? So in 130 days, how many minutes it gains? So 130 into 4 minutes. So 520 minutes. It gains 520 minutes. So this minute, right, it gains in 130 days should be a multiple of 60 minutes. Here 52 or 520 is not it is not a multiple of 60, right? So 16 to 8 is 480 and 16 to 9 is 540. So 520 is not a multiple, right? Multiple of 60, right? No need to check for the second table clock also. So here option A is not the answer. Now consider option B, right? In 135 days, exactly after 135 days, right? Option B, in 135 days, right? Days. So how many minutes it gains? Wall clock, how many minutes it gains? In one day, it gains 4 minutes. Therefore, in 135 days, right? So in 135 days, wall clock gains 540 minutes, right? Gains 540 minutes. That means it completes, if it gains extra 540 minutes means 540 by 60. So which is, it completes 9 more hours, right? 9 hours. 9 extra hours. Therefore, so hands of the wall clock come back to their original position, that is at 12 noon, right? After 135 days. Now consider the case of table clock, right? So in 135 days, so table clock loses how many minutes? In one day, if it loses 4 by 3 minutes, right? So in one day, 4 by 3 minutes. Therefore, in 135 days. So 3 into 4, 3 into 5. So 45 into 4, which is 180, right? So 180 is a multiple of 60. So wall clock loses, right? So it lacks 180 by 60, that means 3 hours, right? So it lacks 3 hours. Therefore, the hands of the table clock, they will be in their original position, right? That means at 12 noon. Therefore, after exactly 135 days at 12 noon, right? So both the clocks, wall clocks and table clocks show the same time. Therefore, option B is the right answer. Students, if you want to practice such questions on clocks and calendars, please visit our website at www.examsnet.com. You can also download our app. The link is given in the description box. Question number 11. In a leap year, the 1st February and 1st of which of the following month fall on the same day of a week? So here, student, we'll just imagine 1st February is on Sunday, right? 1st February is on Sunday. So first date of which of the following months, July, August, April, and September, fall on the same day of the week. So here, first we need to consider number of days in each month, right? So in each of the following months, July, August, April, and September, 4 months, right? So these number of days from 1st February should be multiple of 7, because there are 7 days in a week, right? 7 days make 1 week. So multiples of 7 means, so if number of days from 1st February to end of July, if the number of days are multiples of 7, so that makes a complete weeks, right? So many number of weeks. Therefore, the 1st of next month becomes the same day, which is Sunday. Right? So we'll consider 1st February is on Sunday and number of days on February. Number of days in each month. Right? Here in February, since February is a leap year, it is already given. So there are 29 days. Right? Here 29 is not a multiple of 7, right? There is one extra day. So after 28, therefore, the first of next month, which is March, is not on Sunday, right? So we'll consider month March. There are 31 days, right? So totally, so we'll consider total days here. By the end of March, there are 29 plus 31 days, so which is equal to 60 days. Totally, it is 60. So last day of March is 60th day from 1st February, right? From 1st February, if you count, last day, right? Last day of March is 60th day, so which cannot be Saturday, right? So here, first we need to consider last day of each month should be Saturday, so that next month's first day will be Sunday, right? Here, according to the options, July is given, August, April, and September are given. So we'll consider each month, right? So in April, in the month of April, we have 30 days, right? So starting from February, totally we have 90 days. So last day of April is 90th day, right? So 90 is also not a multiple of 7. So you cannot consider that month also. Next comes May. In the month of May, we have 31 days. So 90 plus 31. So we have 121. So from February, if you count, so there are 121 days from 1st February to last May. So here 121 is also not a multiple of 7, right? So you cannot consider that month. Next comes June. We have 30 days. So totally from 1st February, there are 151 days. So last day of June is 151st day, right? 151. So here 151, is it a multiple of 7? No, you cannot consider. Next comes July. There are 31 days. So totally it becomes 182. Again 182, so 7 into 2. Right? Yes, 182 is a multiple of 7, right? Since 182 divided by 7 is equal to 7 into 2, 14, 7 into 6. So from February, from 1st February, right? So till last July, there are 26 weeks, right? 26 complete weeks. Is to if 1st Feb is Sunday, so last day of July, so 31st of July, so it completes 26 weeks, so it should be Saturday. Last day of July, 31st July is on Saturday. That means next day is 1st August. 1st August, so is on Sunday. Next day of Saturday is Sunday. Therefore, if 1st February is Sunday, 1st August will be on Sunday. If February is a leap year. So that means if the year is a leap year, if there are 29 days in the month of February, then next month in which the first day is Sunday will be August, right? 1st August will be on Sunday. This is how you have to calculate. Come back to the question, which of the following month fall on the same day of the week? So August month, option B is the right answer. August month fall on the same day of the week, right? So that means 1st August will be on same day, right? That means on Sunday. If you take 1st February as Saturday, then 1st August will be on Saturday, right? Like that it goes. So here you need to consider number of days by the end of each month from 1st day of February. That we need to consider. If the total number of days when you count in each month is equal to multiple of 7. So it should be completely divisible by 7. Then that last day completes complete weeks. So there should be complete weeks, 26 number of weeks, or it may be 25, 24, like that. Then the next day, that means in the next month, first day should be the same day, right? This is how it goes. Option B is the right answer. Question number 12. The length of a minute hand of a clock is 7 centimeter. The area swept by the minute hand in 30 minutes. So students, we'll consider a minute hand of a clock. So let it be at 12, right? So we'll consider the minute hand. So its length is 7 centimeter. So when you consider this as a circle, clock as a circle, its radius becomes 7 centimeter, right? So radius is nothing but length of the minute hand. So when the minute hand is swept, right? So in 30 minutes, what is the area swept by the minute hand? So in 30 minutes means, so minute hand, if it comes to the position 6, right? So here it completes 30 minutes. 30 minutes means 12 to 6 is 30 minutes. So in 30 minutes, angle subtended by it at the center is 180 degree, right? So angle subtended by it in 30 minutes. Angle subtended in 30 minutes. So we'll take it as theta is equal to 180 degree. So here we need to find area swept by the minute hand in 30 minutes. So this area you need to find, right? So area swept by the minute hand is equal to, therefore area is equal to, area of the whole circle is pi r square. Here, because of the minute hand, an angle is made at the center which is 180 degree. So the formula becomes pi r square into theta by 360. Here, why it is theta by 360? This area is portion of a circle. So we call it as a sector, right? It is a sector or portion of a circle. Its area becomes a area of the circle into theta by 360. So here theta is angle made at the center by the minute hand, right? Which is 180 degree. We'll substitute the values. Here pi will take it as 22 by 7. R square, radius of this circle is 7 centimeter. R square becomes 7 into 7 into theta is 180 degree by 360. So even no need to consider theta by 360. Since this area is half of area of the circle, directly you can take it as half pi r square, right? Since angle is 180 degree, this whole area, so it is nothing but half of the area of the circle. Therefore, it becomes half pi r square. So if you consider the concept, this concept of area of the sector, so you have to take theta by 360. So in both the ways, you will get the same answer, right? So 7 and 7 will get cancelled. So 180 into 2 is 360 and 2 into 11 is 22. So area of the sector is equal to 77 centimeters square, right? 77 centimeters square, area swept by the minute hand in 30 minutes. Option C is the right answer. Question number 13. The number of relative position of the hands of clock in each of which it is possible for them to change their places in the course of their revolution is. So in the course of revolution of hand of a clock. So consider a minute hand and a hour hand, right? So here, so the time showing is 12 noon, for example, right? So with respect to minute hand, right, our hand is showing, so it is exactly overlapped over minute hand, right? So when it is 12:05, the relative position is, so relative position of minute hand with respect to our hand is changing, right? So there is a one possibility when it is 12 noon, another possibility when it is 12:05, and one more possibility of relative position of minute hand with respect to our hand is when it is at, the time is at 12:10, right? And there is a fourth possibility also when the time is 12:15, when time is 12:20, then 12:25, and there is a seventh position when the time is 12:30, eighth possibility, and ninth possibility when it is 12:45, 10th possibility, then 11 and 12, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Again, it comes back to its same position, right? There are 13 possibilities. 13 possibilities, right? Therefore, each of which it is possible for them to change their places. So for each hand, there are 13 possibilities. So in the course of their revolution. Therefore, option B is the right answer. Question number 14. A clock rings at 1 o'clock, 2 o'clock, 3 o'clock, and so on. The number of times it will ring in a week. So here students, in a day, number of times that a clock rings is 24, right? Because in a day we have 24 hours, right? So in a day, in one day, so clock rings 24 times. For every 1 hour it rings, right? Therefore, 24 times. Therefore, in a week, in 1 week, so how many times it rings? So there are 7 days in a week, right? Therefore, 7 into 24. So it becomes 168 times, right? So in 1 week, so the clock rings 168 times, right? Option B is the right answer. Question number 15. How much does a watch lose per day if its hands coincide every 64 minutes? So students, here we'll consider a clock, right? So we'll consider a time, for example, 1 o'clock, right? So how much does the watch lose per day? So if its hand coincide every 64 minutes means, so instead of 60 minutes, if its hands coincide every 64 minutes, so how much time it loses per day, right? Here students, displacement of minute hand with respect to our hand in 60 minutes. So in 60 minutes means when this our hand, so this our hand, when it completes one complete hour, so its displacement will be 5 minutes, right? Displacement, that means this our hand will get displaced to the place 2 in one complete hour, that means in 60 minutes, right? So that means 55 minutes spaces are covered in 60 minutes, right? Therefore we'll consider 55 minutes spaces are covered in 60 minutes, right? So instead of 1 to 1, it covers 2 to 1, right? I'm talking about our hand, right? So the spaces covered in 60 minutes is 55 minutes spaced. 2 to 3, 3 to 4, 4 to 5, 4 to 5 to 6, right? So up to 1, so 55 minutes spaces are covered in 60 minutes, right? Therefore minutes covered 60 minutes spaces, right? So minutes, how much minutes covered 60-minute spaces. Right here, 60 minutes covered 55 minute spaces. So how much minutes covered 60 minute spaces? So which is equal to, right? So 55, right, minute spaces are covered in 60 minutes. Therefore, 60 minute spaces are covered in how many minutes? So which is equal to, you'll get 65 integer 5 by 11. Right? So 60 minute spaces are covered. So instead of 2 to 1, if spaces covered are 2 to 2, right? 2 to 2, the complete 360-degree spaces are covered in how many minutes? Right? That is equal to 65 minutes 5 by 11 minutes. Right? If the clock completes these many minutes, if 65 integer 5 by 11 minutes, if it completes, then space is covered by our hand, right? Space is covered by our hand, right? So is equal to 65 integer 5 by 11 minutes, right? Here, loss in 64 minutes. What is the loss in 64 minutes? That's what the question is. How much does the watch lose per day? So if the hands coincide every 64 minutes, loss in 64 minutes is, so here spaces covered by our hand, right? So 60 minute spaces are 65 integer 5 by 11 minus 64 spaces, right? Therefore, so you will get 16 by 11 minute. So in 64 minutes, right? So when our hand completes 64 minutes, so loss is 16 by 11 minute. Therefore, loss in 1 day. So 1 day means 24 hours, right? So 16 by 11, right? So that means in 64 minutes, loss is 16 by 11. Therefore, in the denominator, we have 64 and in the numerator, we have 16 by 11, right? Therefore, in 24 hours, right? So 24 hours, here the time is in terms of minutes, so we'll multiply by 60, right? So 24 hours means 24 hour into 60 minutes. So you will get 32 integer 8 by 11 minutes, right? Therefore, in 24 hours, there will be a loss of 32 integer 8 by 11 minutes, right? Therefore, option B is the right answer. So, watch loses 32 point something minutes, that is 32 integer 8 by 11 minutes in a day. So, if its hands coincide every 64 minutes, right? Therefore, option B is the right answer. Question number 16. What is the angle between the two hands of the clock at 4:22 p.m.? So here students will consider a clock. Here the time is 4:22. So here we take 12, 3, 6 and 9, these numbers, and we'll consider 4 and 5 also. Right? So 4:22 means, so the minute hand is at 22, right? So 22 minute hand comes somewhere between 4 and 5, right? Between 4 and 5, somewhere here it comes minute hand, the longest hand, whereas our hand comes somewhere nearest to 4, right? Not exactly on 4, right? Somewhere nearer to 4. So the time is 4:22 p.m., right? 4:22 p.m. Right? Now we need the angle between two hands of the clock. So that means angle between these two hands. So we'll name these hands as AB and BC. Right? Here we need angle ABC. Right? What is this angle? For that, we'll consider our measurement from 12, which is the standard measurement. Right? To measure these angles, we'll consider our standard measurement from 12. So we'll name this point as D or P, with any symbol you can use, right? Any letter you can use. So here angle ABC can be written as angle CBD. The biggest angle here is CBD. This is CBD minus angle ABD. Minus angle ABD. Right? Here angle ABD, this angle which I am showing here, which is the angle swept by our hand. Right? Angle swept by our hand. Whereas CBD is angle swept by minute hand. Minute hand. So how to find these angles? We'll consider that, right? So we'll consider first the hour hand, right? So in a clock, so our hand, it sweeps to half a degree in 1 minute. Half degree in 1 minute, right? Therefore, in 22 minutes, so how many angles it sweeps? Therefore, in 22 minutes, right? So when it is 4 o'clock, minute hand will be on 12, our hand will be exactly on 4, right? When it is 4:22, so our hand sweeps a little bit, right? So in 1 minute, it sweeps half degree, right? Therefore, in 22 minutes, it sweeps half into 22. So to 11 degree it sweeps, right? So instead of position 4, so slightly it moves towards 5. That degree is from 4 to towards 5, it sweeps to angle 11 degree. But angle between 12 and 4 is, so 12 to 3 angle is 90 degree, 12 to 4 angle is 120 degree, right? Therefore, so in 22 minutes, it sweeps 11 degree, and the total angle, what is that angle? ABD. ABD is equal to 11 degree. So small angle subtended by our hand plus 120 degree. 120 degrees angle subtended by minute hand from 12 to 4, right? Therefore, so it is 131 degree. Why do we need this angle? Because to find ABC, the smallest angle here, right? So here angle ABD is 131 degree. Whereas CBD, so how to find CBD, the biggest angle here? For that, we need angle subtended by minute hand. So we'll consider minute hand. So what angle it sweeps in 22 minutes, right? So every minute hand in 1 minute, that means in 60 seconds, it sweeps 6 degrees, right? So 6 degrees in 1 minute. That means if the minute hand is somewhere here at 12, right? In 1 minute means, so between 12 and 1, the first part is 1 minute, right? So here is 1. The first part here it is 1 minute. In 1 minute, it subtends a 6 degree angle, right? 6 degree angle. So minute hand sweeps to 6 degree in 1 minute. Therefore, in 22 minutes, in 22 minutes, how many angles it sweeps? So 22 into 6, it is 132 degree angle. Therefore, angle CBD, the biggest angle made by minute hand, CBD, I think you are getting my point, CBD here, right? So is equal to 132 degrees, right? So we'll consider the CBD and ABD. ABD, CBD are 131 and 132. Therefore, angle ABC, the smallest angle between minute hand and our hand when the time is 4:22 p.m. is CBD is 132 and ABD is 131. Therefore, a small angle 1 degree is made between our hand and minute hand when the time is 4:22. So here our hand minute hands are very closer, right? So 1 degree means very, very small, right? Therefore, angle ABC, so angle between two hands of the clock is 1 degree. Option A is the right answer. Students, if you want to practice such questions, please visit our website www.examsnet.com. You can also download our app. The link is given in the description box. Question number 70. So here is a small correction, students. So the question should be, at what time, right? At what time between 4 and 5 o'clock will the hands of a clock coincide? So between 4 and 5 o'clock, so at what time the hands of a clock, our hand and minute hand, will coincide? So for that, we'll consider the time 4 o'clock, right? Here the minute hand is at 12, our hand is at 4. Here is 4, right? So next position will be 5, next will be 6, right? Here students, let time after which these two coincide be x minutes, right? So after few minutes, so for example, when our hand comes somewhere here, right? So at the same time, minute hand comes over this, right? At this time, so both the hands will coincide, right? So the time after which these two coincide be x minute, we'll consider, right? Let the time after which minute hand and our hand coincide be x minutes. After x minutes, minute hand and our hand will coincide, right? Here students, from 12 to the place, right, where both the hands coincide, right? From position 12 to the place, let it be P, 12 to P, right? Our hand covers 120 degrees plus x by 2, right? Because in 1 minute, our hand covers half a degree, right? So in 1 minute, our hand covers 1 by 2 degree, half a degree, right? Therefore, our hand covers 120 degree from 12 to P, right? 120 degree from 12 to 4, it covers 120 degree. From 4 to P, that means in 20 minutes, it covers x by 2 degrees. So 120 plus x by 2, right? So at the same time, minute hand is also covering some degree, right? In 20 minutes. So here, not exactly 20 minutes, the time after which minute hand and our hand meets, right? So here, our hand covers 120 plus x by 2 and minute hand covers after x minutes. So it covers, for every minute hand covers 6 degree, right? So here in 1 minute, our hand covers half a degree, right? In 1 minute hand covers 6 degree. You can mention here. So in 1 minute, minute hand covers 6 degrees. Therefore, so in x minutes, it covers 6x degrees, right? Therefore, we can say 6x degrees means the whole thing from 12 to P, right? So 12 to P, right? By minute hand, right? Minus x by 2 is equal to 120, right? So x by 2 means, so angle covered by our hand from 4 to P, right? Or you can equate, so the angle covered by minute hand and our hand from 12 to P, right? So by rearranging, so from 12 to P, minute hand covers how much? 6x minus x by 2 is equal to 120. We'll simplify this, right? Since 2 is the LCM, so 12x minus x is 120. 11x is 120 into 2 is 240. So x is 240 by 11. 240 by 11. So 11 into 2 is 22. 11 into 1 is 20. 9 is the remainder. So 21 integer 9 by 11, right? So 21 integer 9 by 11 minutes. So the question is at what time? At 21 minutes or 21 integer 9 by 11 minutes, two hands of a clock will coincide. So between 4 and 5 o'clock at this time, right? So 21 minutes and something or 21 minutes 9 by 11, right? So at this time, two hands will coincide, right? Hence option B is the right answer. Question number 18. When the time is 15 minutes past 5, the angle between two hands of a clock is very easy question. So we'll consider 5:15 time, right? So here the time is 15 minutes past means 5:15, right? So at this, here our hand is on 5, nearer to 5, right? So 3, 6, 9 and 12. And 5, number 5 is here, 4 is here. So here 5 o'clock means the our hand will be exactly on 5. 5:15 means our hand will move slightly towards 6. Slightly towards 6. Not exactly on 5. Right? So 15 minutes means minute hand will be on 3. Exactly on 3. Right? So here angle between two hands. This angle you need to find. Right? Angle theta. So for that, two methods you can use. One is, first let us consider angle between 5 and 3. Right? Angle between two consecutive numbers in a clock is 30 degree. Right? So angle between 5 and 3. So in method 1, directly if you want to take angle between 3 and 5 is equal to, so angle between two consecutive numbers is 30. So 3 and 5 means 30 plus 30, which is 60 degree. Right? So when it is 5:15, in 15 minutes, our hand moves slightly towards 6. Right? So how many angles? To what extent it moves towards 6? That we need to take. Right? So for every minute, our hand moves to half a degree. Right? Therefore, so in 1 minute, our hand moves by half degree, right? Therefore, so what is the minute here? So 15 minutes past 5, right? Therefore, in 15 minutes, our hand moves by, so half into 15 minutes is 7.5 degree. 7.5 degree, right? Therefore, our hand will be 7.5 degree from its original position. Original position is exactly on 5 here, but at this time, 5:15 time, so our hand moves by 7.5 degree. Therefore, total angle between two hands is, total angle between two hands is equal to angle between 5 and 3 is 60 degree plus angle between 5, that is exactly 5, and the final position of 5 is 7.5 degree. So the total angle is 67.5 degree. So is the angle between two hands of a clock when the time is 5:15, right? Hence option B is the right answer. This is the simplest method, right? Another method is, which we have discussed in the earlier examples, we have to consider the measurement from one point, particularly from 12, right? So from 12 to 15 minutes means, so here from 12 to 3, angle will be 90 degree. So this is one angle. right? This portion or this angle should be subtracted from angle from 12 to 5, the final position of 5. So say it as ABC angle, right? Angle ABC. We have to find angle ABC first. How to find angle between 12 to 5 is that we know. So it is 90 degree plus 60 degree, which is 150 degree. So here I'm just showing angle ABC is, so at 5 o'clock angle becomes how much? 150 degree, right? So in addition to 150 degree, so this our hand moves by 7.5 degree, right? Therefore it becomes 157.5 degree. Angle between 12 and final position of 5 or final 5 position of our hand is 157.5 degree, right? So ABC minus 90 degree becomes 157.5 minus 90, so which is nothing but 67.5 degree, right? So in both ways you can find the answer. So the simplest method is first one, directly taking the angle between two hands, right? Therefore option B is the right answer. Question number 19. If June 11th, 1998 was Thursday, what day of the week falls on June 10th, 1999? Here, if you consider June 11, right? So, we'll consider June 11 was Thursday. It was Thursday, right? So, we need to consider June 10th of next year. So next year means June 11th to June 10th of next year. So total number of days are 365 days, right? So here total days are 365 days, right? From June 11th to June 10th of next year, which is 1999, right? Total number of days are 365 days, since any of the given years are not leap years, right? Therefore, the number of days are 365 days, right? So how many weeks we can take in 365 days? So number of weeks are 365 by 7, right? Total number of days in a week are 7 by 7. If you take 7 into 5, then 7 into 2, so it becomes 364. So there are 52 weeks and 1 day in every year, in each year, except leap year, right? So number of weeks are 52 weeks and 1 day. So this last day, 1 day, is June 10th of 1999, right? So this 1 day, last 1 day is June 10th. Whereas in 52 weeks, last day of 52nd week, right? Here, last day of 52nd week, we'll consider that. So which is nothing but June 9th. June 9 becomes the last day of 52nd week, right? It is given that June 11th was Thursday, right? Therefore, last day of 52nd week, so it becomes a day before Thursday. It is Wednesday. Because here Wednesday completes one full week, right? Thursday to Wednesday, it completes 1 week. Therefore, to complete 52 weeks, right? Last day should be Wednesday. Therefore, June 9th was Wednesday, right? June 9th of 1999. Therefore, June 10th should be again Thursday. Right? That's what the question is. If June 11th, 1998 was Thursday, what day of the week falls on June 10th of 1999? Thursday, right? June 10th is Thursday. Hence, option C is the right answer. Question number 20. Any day in April is always on the same day of the week, the corresponding day in. So that means if you consider any day in the month of April, for example, 7th April, right? So the day is 7 here. The date is 7, right? If 7th April is Friday, for example, the same date should fall on the same day in which of the following months, right? The meaning is the same date, 7th, right, should fall on Friday, right, in which of the following months, whether it is in the month of August, June, July, or December, that we need to consider. For that, let us consider number of days from April to the corresponding months, right? So the same date. That means from 7th April to 7th August, 7th April to 7th June, to 7th July to 7th December, right? So if we have one excess day, right, only one excess day, right, when the number of days is divisible by 7, right? So how we can solve, I'll explain here, right? So we'll consider the month August. Here, consider option A, number of days from 7th April, right? So 7th April to 7th August. 7th August. So how many days are they? So which is equal to, so in the month of April, from 7 to, there are 30 days, right? So we are just subtracting for 6 days here. So we are considering 24 days. In the month of May, we have 31. In the month of June, we have 30. In month of July, we have again 31. August, we are considering up to 7, right? 7 days. Totally, we are considering, so 55 plus 30, 85, 86, 116, then 123. There are 123 days from 7th April to 7th August, right? So we'll check whether 123 is divisible by 7 or not. So 123 by 7 becomes, so 49, 4 is the remainder. That means we have 17 weeks between these months, right? These 5 months. So 17 weeks and 4 days. Here the remainder should be 1, right? So it should not be 4 or more than 1, right? Because if the remainder is 1, this extra day becomes the same day, which is Friday, right? Because the 7 days complete 1 week, right? So, right, there are 17 weeks, right? If a first day is Friday, for example, next day will be Saturday and it continues, and the last day will be Thursday, right? And the very next day will be this extra day, which is again Friday. Therefore, we should have 1 as the remainder when the total number of days is divisible by 7, right? So in which of the following months you will get 1 as the remainder, right? So only in such a case, the 7th of that respective month will be Friday, right? So we'll consider option B. Option B, in the month of June, right? So here we'll count 7th April to 7th June, number of days, right? So number of days. So in the month of April, there are 24, we are considering. The month of May, 31. And in the month of June, we are considering only 7 days. Totally 55 plus a 7, which is 62, which is not divisible by 7, of course. But when it is divided by 7, so we have to check whether we get 1 as the remainder or not, right? So 7 into 8, 56, you will get 6 remainder. Therefore, 7th June is not Friday, right? So we'll consider option C, 7th July, right? So 7th April to 7th July. So number of days are, so in the month of April, 24, May 31, June 30, and in the month of July, we are considering 7 days. So totally it is 55 plus 30, 85 plus 7, 92. So when 92 is divided by 7, So it is 7 into 1, then 7 into 3. Yes, 91. So we have 1 as the remainder. So this extra day, right? Extra day is after Thursday, which is Friday. Therefore, so this extra day is 7th July, right? 7th July is on Friday. Therefore, in July month, if you consider one particular date, for example, 7th, right? So 7th July falls on same day. Falls on same day. So any day in April is always on the same day of the week, the corresponding day in July, right? Therefore, option C is the right answer. Question number 21. Find by how many degrees the angle formed by the hour hand and minute hand changes when the time changes from 7:45 a.m. to 7:47 a.m. That means when time changes from 7:45 to 7:47, we'll consider these two times, right? On a clock, here we'll consider 7:45, right? So 7 comes here. Here at 7:45, minute hand will be exactly on 9, right? So our hand will be somewhere between 7 and 8. So here we need to find angle between them, angle between the hands. Whereas in 7:47, we'll consider the time 7:47, right? So 7 and 8, even we take 9. So minute hand will be 7:47 means here. So exactly on 7:47 means exactly on the second part after 9, right? Since there are 5 equal parts between two consecutive numbers, exactly on second part after 9, 7:45 minute hand lies. Whereas our hand will be somewhere closer to 8. Somewhere closer to 8. So here the question is, by how many degrees angle formed by our hand and minute hand in these two cases changes from 7:45 a.m. to 7:47? From how many degrees it changes? So that means angle formed in the first case, let it be A1, right? And A2. So what is the difference between these two angles, right? So we have to find the difference between two angles. Two angles. For that, we'll consider angle formed in each case, right? So here angle formed is, so we can easily consider the whole angle formed when the minute hand is at 45 degree, 45 minute, right? So for that, we'll consider 12 as the standard measurement here. So from this point, we are measuring the angle, right? So when the time is 45 minutes, so the angle formed from 12 to 9 is 270 degree, right? So 270 degree minus angle formed from 12 to the 7 and slightly greater than 7. So angle formed between these two hands. Therefore, so we'll name these points as P, Q, R and S. We need RQS angle, right? So angle RQS is equal to angle PQS minus PQR. PQR, right? So what is PQS? So angle formed from 12 to 9, right? So which is nothing but 270 degree. 270 degree, right? 12 to 6, it forms 180 degree plus 90 becomes 270 degree minus angle PQR. So here, when it is 7 o'clock, just for example, it is 7 o'clock. Angle formed between 12 and 7 becomes 180 plus 60, which is 2, how much? 180 plus 30, which is 210 degree, right? When it is 45 minutes past 7, right? 45 minutes past 7. So this, our hand also moves slightly towards 8. right? So our hand moves by half a degree in every minute, right? So in half degree in every minute. Every minute our hand moves by half degree. Therefore, in 45 minutes, 45 minutes. So to what extent our hand moves? So 45 by 2 degrees, right? Therefore, so angle PQR becomes, so we'll consider angle PQR as, so angle between 12 and 7, which is 210 degree, plus, so slightly the our hand moves by 45 by 2 degrees, right? This is what the concept behind this, right? Therefore, 270 degree minus, here it is 210 plus 45 degree by 2 means 210 plus 22.5, right? Therefore, 270 degree minus 232.5 degree. So it is equal to, yes, 37.5 degree is, so angle between minute hand and our hand when the time is 7:45. Similarly, when the time is 7:47, right? So here, so for this also we'll mention the angle from 12. We'll name it as MNOP, right? So MNOP. So we need MNP. So angle, no, we need MNP and MNO so that you can easily find ONP. So angle ONP. So angle between minute hand and our hand is equal to whole angle MNP minus angle MNO. Here, angle MNP. So from point M, if minute hand sweeps to P, right? Here up to 9 it makes 270 degree. So after that one division is equal to 6 degree. Another division is 6 degree. So 270 plus 12 degree becomes 282 degrees, right? MNP is 282 degree minus MNO. So this one. So when it is 7 o'clock, when it is 7 o'clock, it makes 210 degree. So our hand makes 210 degree with 12 plus, so in 47 minutes, because the time is 7:47. In 47 minutes, our hand sweeps by 47 by 2 degrees. Therefore, it becomes 47 by 2. Total angle from 12 is, angle between our hand and the point 12 is 210 plus 47 by 2, right? Therefore, it is 282 minus 210 plus 23.5 degrees. So it is 282 minus 233.5 degrees. So it is equal to, so 5, then 11 minus 3 is 8, 7 minus 3, right, is 4. So 48.5 degree is angle between minute hand and our hand when the time is 7:47. Here difference between two angles. So when it is 7:47, angle is greater, right? 48.5 degree minus 37.5 degree. So 11 degree is the change in, that means by how many degrees the angle is changed? By 11 degrees the angle is changed, right? From 7:45 to 7:47. So here look at the options. So here the units are not minutes. So these are degrees, right? So angle is measured in terms of degrees. So option C is the right answer, 11 degree, right? So angle between two hands of a clock changed by 11 degrees, right? Option C is the right answer. Students, if you want to practice such questions, please visit our website www.examsnet.com. You can also download our app. The link is given in the description box. Question number 22. If the first day of year 1980 was Tuesday, what was the day on first day of the year 1981? So first day of the year 1980 means Jan 1st was Tuesday. Tuesday. Here 1980 is a leap year, right? So 1980 is a leap year. Right, leap year comes once in 4 years, right? So here 80, the last two digits are 80. 80 is divisible by 4. So when the whole year is divisible by 4, then that year automatically is a leap year, right? Therefore here no need to go for the division of 1980 by 4. So directly you take last two digits. When two digits are divisible by 4, then the whole year is divisible by 4. Therefore it is a leap year. Therefore number of days are, in a leap year there are 366 days, right? Number of days are 366 days. So based on number of days we can decide. So first day of next year will be which day, right? So in 360 days, how many weeks we have? Number of weeks is equal to 366 by 7. So 7 into 5, then 7 into 2 is 14. So 52 weeks and 2 days. Right. So if first day is Tuesday, right? So last day of 52nd week or last day of next week will be Monday. So last day of 52nd week will be Monday, right? So we'll mention Jan 1st is Tuesday. So last day of 52nd week is Monday. So the cycle is Tuesday to Monday, right? So last day of 52nd week is Monday, and we have 2 excess days, right? So these extra days are again next day of Monday is Tuesday and Wednesday. These extra days are Tuesday and Wednesday. So the dates are 30th of December and 31st of December, right? Therefore, 1st January 1981, next year, right? The first day of next year becomes, after Wednesday, it is Thursday, right? Therefore, what was the day on first day of next year? So it was Thursday, right? Option D is the right answer. So first you have to count the number of days in that particular duration, right? 1st January of 1982, the last day, so which is this up to December 31st, right? So 366 days, since 1980 is a leap year. So in 366 days, we have 52 weeks and 2 days. So last day of 52nd week is Monday, right? Right? Because the cycle is Tuesday to Monday. It starts with Tuesday. Therefore, the cycle of weeks ends with Monday. And we have 2 extra days, right, in that year. So these extra days are next day of Monday is Tuesday and next to that is Wednesday. So these dates are 30th and 31st December. Therefore, the next date will be 1st of January in the next year. So which is obviously Thursday. Hence, option D is the right answer. Question number 23. The reflex angle between the hand of a clock at 10 minutes to 4 is. So here the time is 10 minutes to 4. So if you consider the clock, so 12, 9, 6 and 3, right? So 10 minutes to 4 means a minute hand should be at exactly at 10, the longest hand, and our hand will be nearer to 4, not exactly on the 4. Our hand will be so almost nearer to 4. So this gives the time. So for 10 minutes to 4, it is not exactly 4 o'clock, it is 10 minutes to 4, right? So reflex angle between hand of a clock at 10 minutes to 4. So 10 minutes to 4, the corresponding angle is this, right? And the reflex angle is nothing but 350. This is reflex angle. Reflex of the angle made at 10 minutes to 4 is 350, right? Here, reflex angle is made at 3:50. 3 hours 50 minutes, right? 3 o'clock 50 minutes, right? So we need to find angle made by minute and hour hand at 3:50. That gives the reflex angle. Right? So reflex angle means it's opposite angle or angle formed at 4:10 or sorry 10 minutes to 4, angle formed at 10 minutes 4. When this angle is subtracted from the whole angle which is 360 degree, you will get reflex angle made at 3:50, right? So for that, we'll consider the angle made between minutes and hour hand when the time is 3:50. Very simple question. So here, just we are taking 12 as the standard number from which we are measuring the angle, right? From 12, right? From 12 to 10, here the minute hand makes an angle. So 270 plus 30 degree, which is 300 degree of angle, right? Therefore, angle made by minute hand from 12 is equal to 300 degrees. So from 12 to 9, it becomes 270 degree plus 30 degree. 9 to 10, there are the angle between any two consecutive numbers in a clock is 30 degree. So 30 plus 270 becomes 300 degree, right? Now angle made by our hand. From 12 to not exactly 4. So nearer to 4. Right? Since it is 3:50, so when angle is made at 3 o'clock, for example, so angle made by 12 and 3 is 90 degree plus, so for every minute, our hand moves by half a degree. That we know, right? In 1 minute, our hand moves by half a degree, right? Therefore, here in 50 minutes, our hand moves by 50 by 2. 50 into half or 50 by 2 degree. Therefore, so when the time is 3 o'clock, angle between 12 and 3 is 90 degree. When the time is 3:50, it becomes 90 degree plus. So in 50 minutes, our hand moves by 50 by 2 degrees, right? Therefore, it is nearer to 4, right? Therefore, total angle made by our hand from 12, that you have to mention. From 12, it is equal to 90 plus 25, right? So which is equal to 90 plus 25, 115, right? 115 degree. Therefore, angle made at 350. Angle made at 350. That means 350 is equal to, so angle made by the minute hand from 12 to this 50 minutes, which is 10, it is equal to 300 degrees minus angle made by our hand is 115 degree. So which is equal to 185 degree. This is the reflex angle made at 10 minutes to 4. Right? 185 degree is reflex angle. Reflex angle made at 10 minutes to 4. For this angle made at 10 minutes to 4, so the reflex angle is 185. It's a opposite angle, right? Therefore, option D is the right answer. Question number 24. When the two hands of a clock are straight in opposite direction, the angle between two hands is a very easy question. When two hands, we'll consider an hour hand and a minute hand which are straight in opposite direction. Right? This is our hand and minute hand. This is minute hand. So which are straight in opposite direction, right? So the angle between them is it's a straight line. Therefore, the angle is 180 degree, right? Therefore, option C is the right answer, right? So in another case, when two hands are straight in same direction, so one hand is coincided with the other. So this is our hand, and the longest hand is minute hand. So minute hand is coincided with our hand, right? Then angle formed between them is 0 degree. When these two hands are opposite in direction, which are straight, angle between them is 180 degree, right? In another case, you can take it as 0 degree or 360 degree, right? Both ways you can consider. But for the given question, it is 180 degree, right? Option C. Question number 25. If a clock shows 8 o'clock, then the angle between two hands is. Very easy question. So here we'll consider the time as 8 o'clock, right? 6, 7, 8, and we'll consider 9, then 10. So directly we'll consider 12, right? So at 8 o'clock, our hand will be exactly on 8 and minute hand will be exactly on 12. What is the angle between these two hands? This is minute hand and our hand. Since the numbers in a clock are numbered as 1 to 12, right? 1 to 12, there are 12 numbers. And the total angle formed at the center of the clock is 360 degree, right? So here, total angle is equal to 360 degree formed at the center of the clock. And number of parts are 12, right? So angle between any two consecutive number, right? You can consider 1 and 2, 12 and 1, 2 and 3, any two consecutive number. Angle between any two consecutive, you have to mention this, consecutive number in a clock is equal to, so here it is 30 degrees. Since there are 12 parts, it becomes 360 by 12. So which is equal to 30 degree, right? So if you consider 8 and 9, the angle between 8 and 9 is 30 degree, right? So here at 8 o'clock, so at 8 o'clock, there are 1, 2, 3, 4 parts you have to consider. 8 to 9, 9 to 10, 10 to 11, and 11 to 12. So angle between two hands is equal to, so required angle between two hands is equal to, so 30 into 4, right? So we are considering 4 parts, right here, right? So we are taking 4 parts under consideration. Therefore, it becomes 30 degree into 4, which is 120 degree, right? 8 to 9, it is 30 degree, plus 9 to 10, it is 30 degree, plus 10 to 11, plus 11 to 12. Totally, it becomes 120 degree. Therefore, option B is the right answer. Angle between the two hands when the time is 8 o'clock is 120 degree. If the question is asked like, what is the reflex angle between two hands of a clock when the time is 8 o'clock? So then the reflex angle becomes, if the angle is a reflex angle, then it becomes 360 minus 120 degree. So the total angle at the center is 360 degree minus angle between two hands when 8 o'clock is 120 degree, it becomes 240 degrees, right? So reflex angle is an angle which is greater than 180 degree. Always it should be great, it is greater than 180 degree. So if it is less than 180 degree and greater than 90 degree, we call it as obtuse angle, right? If angle X lies between 180 and 90 degree, it is called obtuse angle, right? Here in this particular case at 8 o'clock, angle formed is obtuse angle, right? So it's a reflex angle. If the question is asked like find the, or what is the angle between, or the reflex angle between two hands of a clock when the time is 8 o'clock, in that case the angle is 240 degrees. So don't get confused between option A and B, right? Option A is different, it is a reflex angle. But in the general case, if the question is asked in a straight way, that angle between two hands when 8 o'clock, then the angle will be 120 degree. Option B. Question number 26. January 1, 2004 was Thursday. What day of the week will be January 1, 2005? So very next year, right? The first day of the very next year will be what day? Very straight question, very simple. We have discussed it in the earlier questions here. So students, 2004 is a leap year, right? So 2004 is a leap year. So how to find leap year? If last two digits of a year are divisible by 4, then the particular year is a leap year. So it comes once in 4 years, right? Therefore, it should be the last two digits should be divisible by 4, right? So 2004 is a leap year. So there are 366 days, right? So number of days are 366 days, right? So first Jan is Thursday. So Jan 1st is Thursday, right? So we'll find how many weeks are there in that particular year, right? Therefore, number of weeks in that particular year. So divide the number of days by 7. So you will get 7 into 5, 7 into 2, 52 weeks and 2 extra days, right? So in that 52 weeks, first day is Thursday, right? So the last day of the last week, right? So the last day of the week is obviously Wednesday. So right. So it starts with Thursday and ends with Wednesday. Last day of last week, which is 52nd week, is obviously Wednesday. Wednesday. Right? But there are 2 extra days, right? These days are 2 extra days are so next day of Wednesday is Thursday and Friday. And the dates are, so last dates of December are 30th and 31st of December. 30th and 31st of December, right? Therefore, 1st January, right? 1st January of the next year, 2005, should be next day to Friday is Saturday. Because 31st December was Friday, therefore 1st January 2005 was Saturday, right? Therefore option C is the right answer. Question 27. What is the angle between the time hands at 2:20 a.m.? So very easy question. So we'll consider the time 2:20, right? So 12, 3, 6, 9. We'll consider 1, 2, then 4, right? So here at 2:20, minute hand will be exactly on 4. This is minute hand. And our hand will be somewhere nearer to 2, not exactly on 2. This is 2:20, right? Angle between these two hands, minute hand and our hand, right? For that, so we'll consider from 12. So how the angle will be measured? So from 12, we'll measure the angle. So 12 to 4, the angle is 90 plus 30, which is 120, minus 12 to 2, slightly greater than 2, right? So because our hand is not exactly on 2, right? So after 20 minutes, it slightly moves towards 3, right? First, we'll consider angle between 12 and 4 is equal to 120 degree, right? 120 degree minus angle between 12 and our hand at present gives angle between our hand and minute hand at 2:20 a.m. Do you agree? Right? So now at 2 o'clock, right? So angle between 2 and 12 is equal to 60 degree. So angle between 2 and 1, it is 30 degree, because so in a clock, angle between two consecutive numbers is always 30 degree. Since the clock is divided into 12 main parts and there are totally 360 degrees angle, right? So the total angle at the center is 360 degree, by 12 gives 30 degree. Since there are two parts when the time is 2 o'clock. So 12 to 2. So the angle is 60 degree. When it is 2:20. So at 2:20, 220. So this our hand moves slightly by some degrees, right? Along with the minute hand, our hand also moves. For every minute, our hand moves by half degree, right? So in 1 minute, our hand moves by half degree. Half degree. Therefore, in 20 minutes, our hand moves by 20 by 2, which is 10 degree, right? Therefore, angle between 12 and minute hand, our hand is equal to angle between 12 and 2 is 60 degree, but our hand is moved by 10 degree. 60 plus 10, which is 70 degree. Therefore, this angle, required angle between minute hand and our hand is, therefore, angle between minute hand and our hand is equal to, so angle between 12 and minute hand. So the whole angle is how much? 120 degree minus 70, right? So 120 minus 70 degree, you will get 50, right? So at 220, so at the time 220, angle between our hand and minute hand is how much? 50 degree. Option B is the right answer. Question number 28. For a certain month, the dates of 3 of the Sundays are even numbers, then the 15th of that month falls on. So here in a month, 3 Sundays should be even numbers, right? It is possible only when the first Sunday is the second of that month, right? So we'll consider all Sundays. So Sundays, first Sunday should be second, right? And the second Sunday will be 9th of that month, right? Third Sunday will be 9 plus 7, which is 16th of that month. Fourth Sunday will be 16 plus 7, which is 23. And the fifth Sunday will be 23 plus 7, which is 30. Right? If you consider total number of days in a month as 30, even if you consider 31 also, the next day will be Monday, right? So if first Sunday is, that means on second of that month, then there will be 3 Sundays which are even numbers. Second, 16th and 30th of that month. Then the question is, the 15th of the month falls on. So 16th is a Sunday, right? 16th is a Sunday. Therefore, 15th of that month is Saturday. It falls on Saturday, right? Therefore, option C is the right answer. First, you need to consider which date of that month falls on Sunday. So, first Sunday, right? So, second of that month, if it is falls on Sunday, then there will be 3 Sundays which are even numbers. So, second, 16th of that month and 30th. Therefore, 15th of that month falls on Saturday. Option C. Question 29. One of the following is a day which cannot be the last day of the century. That day is among 4 options. So one of the options cannot be the last day of the century, right? For this, you should know the concept of Anno Domini and the first day of Anno Domini 1, right? So AD 1, which is also termed as Anno Domini. Anno Domini is the first day, right? So first day of the Gregorian calendar is considered as 1st January of Anno Domini 1, right? So it is Jan 1st of AD 1, Anno Domini 1, right? So here Jan 1st of Anno Domini 1 was Monday. We all know that. So it was Monday, right? So here the question is, coming back to the question, so one of the following days cannot be the last day of the century. So we'll consider first century. That means in 100 years, So how many days are there in 100 years? First we need to consider. And how many odd days are there in 100 years? Right? So 100 into 365 days, and there are 25 leap years in 100 years, because leap year comes once in 4 years. Therefore, number of days we'll consider, number of days in 100 years are, so totally it is 365 into 100, which is 36,500 days, plus 25 days extra. So which is because of leap years, right? So totally it is 36,500 plus 25. So it is 36,200 and, sorry, 525. 36,525, right? 525. So how many extra days are there in 100 years? That we need to consider. So extra days. So that means, so when this 36,525 is divided by 7, right? So you will get 5 extra days, right? So these are called odd days. Odd days, right? So odd days are 5 days. So that means there are few weeks, right? So after that there are 5 extra days. These are called odd days, right? So in the next 100 years, so that means in 200 years, right, if you count like this number of days, so you will get 3 odd days. 3 odd days means 3 extra days. So here in first case, in first 100 years, there are extra 5 days. So these extra first day will be on again Monday, right? Because Anno Domini 1, first day of AD 1 started on Monday, right? And the week ends with Sunday, right? So 1 week ends with Sunday, and the next week it starts with again Monday. Therefore, first day in the extra odd days, so first day will be Monday, then Tuesday, Wednesday, Thursday, and Friday. Therefore, we'll consider the last day in 100 year. So it is Friday, right? We'll consider the last day. Here is Friday. That 5th day will be Friday, right? Next, in next to 200, that means 200 years, so there will be 3 odd days, right? So after dividing total number of days by 7, so you will have 3 as the remainder. These 3 days are odd days. So in which first day is obviously Monday, right? Second day is Tuesday, third day is Wednesday. So last day of second century will be Wednesday, right? Now, last day of third century, 300 years. In 300 years, you will have only one odd day. One odd day means, so apart from the last day of the last week, there is one extra day, which is Monday. Which is Monday, because last day of the week always it is Sunday, right? According to Anno Domini concept, right? So in the next 100 years, that means in 400 years, 4 centuries, so there are no extra days or odd days, right? Therefore, last day, there is no extra day. Therefore, last day of the 400th year, so it is always Sunday. Sunday, because 400 years complete number of weeks completely with no remainder, right? Therefore, the number of, or the days, right, which can be the last day of century are Friday, Wednesday, Monday, and Sunday, right? There are 4 possibilities, and this cycle continues, right? Cycle continues. So if last day is Sunday, next day will be, next day of 5th century will be again Monday, right? And the cycle continues. So the last day will be Friday. So in the next century, last day will be Wednesday. In the next century, that means 4 plus 3, 7th century, last day will be Monday, next Sunday, and this cycle continues. Therefore, last day of a century cannot be, it cannot be Tuesday, then it can be Wednesday, it cannot be Thursday, and it cannot be Saturday, right? Therefore, last day of a century cannot be a Tuesday, Thursday, and Saturday. Except these 3 days, so last day can be any other day, any other 4 days. Therefore, according to the given options, Sunday is given, Monday is given. Yes, Tuesday cannot be the last day of the century. Not a year. Tuesday cannot be the last day of the century. Right? Therefore, option C is the right answer. Question number 30. If the clock started at midnight, then what is the angle turned by the hour hand at 2:45 a.m.? So here students, clock started at midnight means at 12, right? Clock started at 12. So here we'll consider hour hand at 12, right? So angle subtended by hour hand at 2:45 a.m. So here is 1, here is 2, number 2, here is 3, right? At 2:45 a.m. means the hour hand comes somewhere here, right? Somewhere in between 2 and 3, so which is nearer to 3, right? Particularly. Therefore, in this duration, angle subtended by hour hand, right? From 12 to this point. So, what is the angle subtended by hour hand? Here, from 12 to 2:45, right? So, the total minutes are, so here 12 to 2:45 means 2 hours 45 minutes, right? So, 2 hours 45 minutes means 2 hours means 120 minutes plus 45 means 165 minutes in 2 hours 45 minutes. So in this duration, what is the angle subtended by our hand, right? Here, for every minute, angle subtended by our hand is half a degree, right? So in 1 minute, angle subtended by our hand is equal to half a degree, 1 by 2 degree. Therefore, in 165 minute, angle subtended by our hand is 165 by 2, which is 82.5 or 82 and half degree. Therefore, minute hand subtends an angle 82 and half degree, right? With the hand at 12, right? So with its previous position, original position, it subtends an angle of 82 and half degree when the time is 2:45 a.m., right? So if it is 2:45 p.m., so you have to add 360 degree, because at 2:45 p.m. it completes one complete rotation, which is 360 degree plus 82 and half, right? So you have to add 360 degree. Since it is am, we are just taking the direct angle subtended by it. So by dividing it by 2, the number of minutes, 165 minutes by 2, you will get the angle subtended by it. Hence, option C is the right answer. Students, if you want to practice such questions, please visit our website www.examsnet.com. You can also download our app. The link is given in the description box. Question number 31. Any relative position of the hands of a clock is repeated how many times in every 12 hours? Here students, relative position means position of one hand with respect to another, right? So for example, if minute hand is at 3, right? Our hand is at 12. It becomes 12:15, right? So with respect to, that means with respect to our hand, minute hand is to the right. This is relative position of the minute hand with respect to our hand, right? So here another case is at 12 o'clock. So 12 noon or 12 midnight. Here minute hand is overlapped, right? Over the our hand, right? So they coincide. This coincidence is also a relative position, right? Position of one hand with respect to another, right? You can consider any position, right? So you may consider 12:45, in which minute hand is to the left, right? So when it is 12:45, minute hand is to the left. This is also relative position. If it is 12:30, right? Minute hand is opposite to the hour hand. These are all relative positions. Here the question is, any relative position of the hands of a clock is repeated how many times in every 12 hours? So here we'll consider relative position as overlapping one hand over the other, right? For example, at 12, right? At 12, this is coinciding, right? So one hand is coinciding over the other, one hand is overlapping, right? Therefore, this is also relative position. So this coincidence, right? So will be repeated how many times in 12 hours? So we'll consider the timings 12 to 12, right? Maybe 12 noon to 12 midnight or 12 midnight to 12 noon, right? So between these two, so in the duration of 12 hours, so at 12 noon, at 12, so one hand will be overlapped over the other, right? And this repeats again at 1 5, right? After 65 minutes, it repeats this overlapping or coincidence. It repeats because the minute hand and our hands align every 65 minutes. For every 65 minutes, 65 minutes, it repeats, right? This overlapping repeats, right? Therefore, so the next time it occurs at 2:11. Here, so between 1 5 and 2:11, there are 66 minutes only in this duration. So this overlapping takes place after 66 minutes, right? So next timing is 3:16, right? Then at 4:21 it takes place, then 5:26, then 6:31, then it occurs at 7:36, and it continues, right, up to 12, right? So next it will be 8:41, then 9:46, then 10:51, right? But after that it will be 11:56. So between 11 and 1 o'clock, so between 11 here, imagine minute hand is here, sorry, our hand is here at 11. So between 11 and 1 o'clock, so only one time, 11 and 1 o'clock, only one time this coincidence takes place, right? Overlapping minute hand over the other one, right? Our hand, right? Therefore, so between 11 and 1 means at 12 o'clock it takes place. Therefore, after 11, this relative position or coincidence will not take place, right? Therefore, how many times, number of times the relative position of the hands will be repeated in every 12 hours is, so here at 12, then second time it is 1 5, so 2 times 3 4 5 6 7 8 9 10 11, right? So 11 times it will be repeated in every 12 hours, right? So here why it is not 11:56? So this won't take place at 11:56 because between 11 and 1 o'clock, right? So this incidence or coincidence or relative position will take place only once. Therefore, here it is already 12 o'clock, there it takes place. Therefore, so 11:56, this incidence or coinciding or overlapping one hand over the other will not take place. That's the reason. Therefore, in 12 hours, 11 times this will take place. So, in a day, so 11 into 2, 22 times this will take place, right? Therefore, option B is the right answer. Question 32. What was the day on 1st January 2018? So here, what was the day on 1st January 2000 Anno Domini, right? So for this, so we'll consider Anno Domini concept, right? So in 1st Anno Domini, right? 1st Anno Domini, so Jan 1st was Monday. Jan 1st was Monday, right? So in 1st century, right? So in 100 years, right? So there were totally 5 odd days. Odd days are nothing but, so when total number of days in 100 years, when these total number of days are divided by 7 or divided by 1 week, so you will get lastly 5 extra days, right? So the total number of days will not be completely divisible by 7. So you will have 5 odd days in total of 100 years, right? So these odd days are the starting from Monday, Tuesday, Wednesday, Thursday, and Friday. Last day will be Monday, Tuesday, Wednesday, Thursday, and Friday. Friday will be the last day, right? In 100 years. Whereas in the next 100 years, so there will be 3 odd days. 3 odd days. So in the third century, so totally, so there is only 1 odd day. If you consider the total number of days in 300 years, when it is divided by 7, you will get only 1 as the remainder, which is the extra day, right? So in 400 years, in 4 centuries, so you will have 0 odd days. So when all the number of days, so when the number of days are divisible by, when it is divided by 7, you will get 0 as the remainder. So 0 extra day or 0 odd days, right? So here 2000 AD. So 2000 AD, here 400 year means 400 AD. Since 2000 AD is a multiple of 4th century, right? Since 2000 AD is a multiple of a multiple of 400 year, right? Or 4th century. Then number of odd days in 2000 AD. So in that year is equal to 0. Since 400 year has a 0 extra or odd days, so 2000 AD also has a 0 odd days, because this cycle, extra days 5, 3, 1, 0, this cycle it repeats, right? So for every 400 year it repeats, right? So in 500 year, so in the next century, again 5 odd days will come in that year, right? And in the 600 year, there will be 3 odd days. Like that it repeats. Therefore, so in 2000 AD, there will not be any extra day or odd days, right? Here the question is 1st January 2000 AD. So we'll focus on the year 2000 AD, right? Since 2000 is a leap year, right? It is a multiple of 4, right? It is a leap year. So there are 366 days. And there is no odd day. There is no odd day means last day of 2000 AD is Sunday, right? So last day, that is 31st January, is Sunday. Because Anno Domini started on Monday, Jan 1st of 1 Anno Domini AD started on Monday. So it's the last day, since there are no extra days, right? So after 2000 AD, that means by the end of 2000 AD, we don't have any extra day. Therefore, it completes one cycle. That means it is a multiple of 7. Therefore, last day will be Sunday. So we'll come in reverse manner, right? So 366 days. Since 364 is a multiple of 7, right? Therefore, 364 plus 2 days, right? So these last 2 days are Saturday and Sunday. Last 2 days are Saturdays and Sundays, right? And its previous day, 364th day, is Friday, right? And in that week, if the week ends with Friday, it starts with Saturday, right? So there are how many weeks? 52 weeks. 364 means 52 weeks in that year, 2000 AD, right? In that, last day of 52nd week is Friday, which is 364th day, right? and its first day was a Saturday. Like that, when you come back, the first week, in the first week, first day is Saturday, right? So first day of first week is 1st Jan, right? First day of first week is Jan, which is Saturday, right? Right? And it's last day. So last day of first week will be Friday, and it continues up to 52 weeks, so that we will have 2 extra days, Saturday and Sunday. So 31st December will be Sunday, and 1st Jan of that year 2000 AD is Saturday, not Friday, it is Saturday, right? Therefore, come back to the question, what was the day on 1st Jan? It was Saturday, right? Option C is the right answer. Question 33. What was the day on 28th June 2000 if 31st May 2000 was Wednesday? So here 31st May was Wednesday, right? So next day will be 1st June. 1st June, right? So first June will be Thursday, right? So 1st June will be the Thursday. So we need to find the day on 28th June, right? So 1st to 7th, if it is 7th June, if 1st June is Thursday, 7th June will be again Wednesday, right? Next comes 8th June, right? So multiples of 7, right? So 8th June will be again Thursday, and 14th June will be Wednesday. And this cycle repeats, right? 15th will be Thursday, 21st June will be again Wednesday. So after 21st, 22nd June will be again Thursday, right? And 28th, it continues, 28th June will be Wednesday, right? Therefore, so 28th June is on Wednesday, right? Option B is the right answer, right? So here it depends on 1st June. So if it is Thursday, right? So 7th June will be, so previous day of Thursday is Wednesday, right? So like that you have to continue. So you hear, student, what was the day on 28th June? So the day on 28th June was Wednesday, right? If 31st May was Wednesday, so 28th June also on Wednesday. Option B is the right answer. Question 34. Which one of the following countries the Gregorian calendar is not accepted, not used? So here in Russia, right? So the Russia country, so in which the Gregorian calendar is not used, right? So in Russia, the Gregorian calendar was accepted after the October Revolution, right? So after the October Revolution, the Gregorian calendar was accepted, right? On 24th January 1918, right? 24th January 1918, the Council of People's Commissars issued a decree that Wednesday, 31st January 1918. So on this day, so the Council of People's Commissars issued a decree, right? That Wednesday, that was 31st Jan 1918 was to be followed by Thursday 14th February. So this should be followed by Thursday, so which is 14th February 1918. So thus dropping 13 days from the calendar. They dropped 13 days from the calendar, right? Therefore, here the country Russia, right, did not accept Gregorian calendar, right, directly. So instead, these many days, 13 days were dropped, right? Therefore, option C is the right answer. Question 35. Through how many degrees a minute hand moves in 1 hour 20 minutes? So here students, we all know that in 1 minute hand moves by 6 degrees, right? So in 1 minute means in 60 seconds, right? So minute hand moves by 6 degree. So that means, so we'll consider a minute hand exactly on 12, right? When it completes 1 minute, right? So that means when it is at 1 minute, for example, right? It completes 6 degree, right? For example, here is 1, right? So between 12 and 1, there are 5 equal divisions, right? And angle between 12 and 1 is 30 degree, right? So each division indicates 1 minute, right? So between 12 and 1, there are 5 divisions. Each division indicates 1 minute, right? So which is nothing but 1 minute is equal to 30 degree by 5 divisions, which is 6 degree. Therefore, in 1 minute, minute hand moves by 6 degrees. Therefore, in 1 hour 20 minutes, so 1 hour 20 minutes is nothing but, so 1 hour is 60 minutes plus 20 minutes, so which is 80 minutes. Right? In 80 minutes, minute hand moves by 6 degree into 80. So which is 480 degrees. So in 1 hour 20 minutes, minute hand moves by 480 degrees. Right? Therefore, option D is the right answer. Question number 36. How many times does the 29th days of the month occur in 400 consecutive years? So in 400 consecutive years, so how many months have 29 days? That is what the question is, right? So we'll consider the normal months in which we have generally 29 days. So we have generally 30 or 31 days except February, right? So we'll consider in 1 year. In 1 year, we have 11 months. Totally, we have 12 months, in which 11 months have 29 days, right? So, except February. Therefore, in 100 years, so how many months have 29 days? So, 11 into 100. So, which is 1,100 months have 29 days, right? Therefore, in 400 years, how many months have 29 days? So, 1,100 into 4. So in 1 century, if we have 1,100 months, in 4 centuries, we have into 4, which is 4,400 months have 29 days. So in 4 centuries, so compulsorily 4,400 months have 29 days, right? So along with this, we have leap years also. In 400 years, how many leap years do we have? For that, we'll consider 1 century. So we'll consider leap years, right? So in 1 century or in 100 years, we have 24 point something leap years. Out of 100 years, we have 24 point something leap years, right? In each leap year, we have 129 day. So except the remaining 11 months, so we have one more month which has 29 days, right? Therefore, so we have month February, right? So in which we have 29 days, so which is 1 month. In 1 month, we have 29 days. Therefore, in 24 point something years, right? In 1 year, if we have 1 month, right? In 24 point something, so we have 24 point something months, right? So in which we have 29 days. Therefore, in 400 years, in 100 years, if we have 24 months in which we have 20, that means 29 days. Therefore, in 400 years, 24 point something into 4, you will get approximately 97 months. Right? So 4,400 plus 97 months in which we have minimum 29 days. Right? So totally in how many months we have 29 days in 400 centuries, 400 years or 4 centuries. So totally, so we have 4,400 months plus 20, sorry, it is 97 months, right? 97 months. It is 4,497 months, right? In these many months out of 4 centuries, right? So out of 400 years, right, into those many months, right? So out of those many months, we have 4,497, in which we have 29 days, minimum 29 days. Hence, option C is the right answer. I'll repeat once again. So, students, out of 4 centuries or 400 consecutive years, so in which 4,400 months we have compulsorily 29 days, right? Minimum 29 days we have, right? So for example, January, March, April, May, June, July, August up to December, except February. In 4,400 months we have 29 days, right? So along with this 4,400 months, we have the months, right, of leap years also. So in every leap year, we have February, which has 29 days, right? So in 100 years, there will be 24 point something leap years. Why it is something 24 point something? Because 1 year means 365 point something days. These point something days will add up to one leap year, right? Therefore, so 1 year in the sense 365 point something days. Therefore, 4 year becomes 366, right? So when it is rounded off, which is approximately 366, so sometimes you get 360 point something, right? So together in 100 years, so you will have 24 leap years, right? That means in each leap year, if you have 1 month, right, in which 29 days, so in totally in 24 leap years, so number of months in which we have 29 days is equal to 24 point something months, right? Therefore, in 400 years, so 24 point something into 4 gives you approximately 97 months, right? So in 400 years, right, 97 months will have 29 days, right? Along with this, 4,400 months have compulsorily minimum 29 days, right? Therefore, together it becomes 4,497 months, right? So it occurs 4,497 times, right? So in which each month has minimum 29 days. Option C is the right answer. Question 37. Find the length of the minor arc at 20 past 1 if the length of the minute hand is 12.6 centimeter, right? So we'll consider the time which is 20 past 1, which is 1:20. Here the time is 1:20, maybe AM or PM, right? So we'll consider the time here, right? So 3, 9, right? So 20 minutes past 1 means the minute hand will be on 4, right? This is minute hand, and length of the minute hand is given 12.6 centimeter, right? Here, length of the minute hand can be considered as a radius of the circle. If you consider this clock as a circle, so its radius becomes length of the minute hand, so it is 12.6 centimeter. And the time is 20 past 1. So here is 1 and 2. Here our hand is somewhere between 1 and 2. Not exactly between 1 and 2, somewhere, so nearer to 1, right? So here we need angle made by the minute hand and hour hand when the time is 1:20. So what is the question? Length of the minor arc. So minor arc is made by minute hand and hour hand. So if you extend our hand up to here and name these 2 points as A and B, right? A and B. So angle made made by minute hand and hour hand, it decides length of the minor arc AB. We need to find value of AB or length of AB, right? It depends on angle made by minute hand and hour hand. So let us find that, right? So angle made by or angle made at the time 120. What is the angle? So if you consider this angle as AOB is equal to angle AOB, right? How to find angle AOB? For that, we'll consider length OC, right? So let the point C be at 12, right? From 12, we can easily measure the angles, right? Because from 12 to 4, the angle is 120, right? So if you take angle COB minus angle COA, right? So the whole angle, big angle COB minus COA gives angle AOB. What is COB? COB is nothing but angle made by the minute hand in 20 minutes. From 12 to 4, it makes 20 minutes, right? So this is angle made by minute hand, right? So angle made by minute hand in 20 minutes. In 20 minutes. So in 1 minute, minute hand will be moved by 6 degrees, right? We all know that. So in 1 minute, so it moves 6 degrees. Therefore, in 20 minutes, it moves 120 degrees, right? Therefore, angle COB, so it is nothing but angle made by the minute hand, which is 120 degree, right? COB is 120 degree. We'll consider angle AOC or COA. So which is nothing but angle made by our hand. Our hand in how many minutes? In 20 minutes. So which is nothing but in 1 minute, our hand can be moved by half a degree, right? So half a degree in 1 minute. Therefore, in 20 minutes, right? Plus, along with this, from its original position, from 1, right? When it was 1 o'clock, the position of our hand was here, exactly on 1, right? In 20 minutes, so it moved by 10 degrees, right? From 1 to somewhere in between 1 and 2. But from 12, angle between 12 and 1 is 30 degree. Therefore, we have to add 30 degree also, because we are going to measure COA 12 to the R hand, right? Therefore, so plus 30 degree, right? Therefore, 10 degree plus 30 degree, which is 40 degree. So, which is nothing but angle AOC or COA. Therefore, angle AOB, we need angle AOB, right? Therefore, AOB is AOB, angle made by minute hand and hour hand is COB is 120 degree minus AOC is 40 degree. Therefore, it makes an angle 80 degree at the center. Therefore, AOB, angle made by minute hand and hour hand is 80 degree. So, what is the question? We need length of the minor arc AB. So, we all know that minor arc, it may be major arc or minor arc. So, AB formula says, since it is a part of the circumference, formula says 2 pi r into theta by 360, right? Which is length of arc, maybe minor or major, right? Here theta is angle subtended at the center by the arc. It is 80 degree here, right? Therefore, we'll simplify it. 2 into 22 by 7. Here r is radius of the circle, which is nothing but length of the minute hand. It is given as 12.6 centimeter. So 12.6 into theta is 80 degree. So angle subtended at the center by 360. So we'll simplify it, since 7 into 8. So 1.8. Now, still we can simplify. So 1.8 into 200 is 360. And now can cancel 1 0. So 4 into 2, 4 into 5 is 20. right? So we have 22 into 244 into 288 by 5, right? So 88 by 5 gives you 17.6 centimeter. Length of the minor arc is 17.6 centimeter. Hence option C is the right answer. Question number 38. At what time between 5 and 6 o'clock the hands of clock shall be straight in opposite direction? So hands of the clock means minute hand, hour hand shall be straight, right? So at what time? So between 5 and 6 o'clock. Here option A says 6 o'clock. So we'll show that, right? So here at 6 o'clock, right? Our hand will be on 6 here, right? And minute hand will be exactly on 12. Since 6 and 12 are opposite to each other, so the hands of the clock shall be straight here, right? Therefore, option A is the right answer. Whereas in the remaining options, we'll consider option B, 55 minute past 5. So we'll show it in a clock. 55 minutes past 5 means, so 6 is here, 5 will be here. So our hand will be not exactly on 5 here, right? 55 minutes past means, so it is very nearer to 6. And 55, since 60 minutes is on 12, 55 will be on 11. So this will be somewhere, yes, which is exactly on 11, not somewhere. So 55 minutes means on 11. So this is 55 minutes past 5, right? Here two hands are not in opposite direction, not exactly in a straight line, right? And also not exactly in opposite direction. So there is an angle, right, which is less than 180 degree, right, between these two hands. Therefore, option B is not the answer. So consider option C, 5 minutes past 6. So we'll consider third one, 5 minutes past 6. Here is 12. So 5 minutes past 6 means minute hand will be on 1. If it is 1, on 1. So 6 is here. So in 5 minutes, 6 is here. In 5 minutes, so our hand sweeps to some angle, somewhere here, right? In 5 minutes. So these two hands are not straight line. They do not form a straight line, right? That means they are not exactly in opposite direction, right? So option C is also not the answer. Therefore, exactly at 6 o'clock, the hands of the clock shall be straight, right? Hence, option A is the right answer. Question number 39. Two clocks begin to strike 12 together. One strikes its strokes in 33 seconds and another in 22 seconds. What is the interval between the sixth stroke of the first and eighth stroke of the second? So here students will consider two clocks, clock 1 and clock 2. Right? So both the clocks begin to strike at 12 together. So exactly at 12. So first strike takes place, strike 1. Right? So strike 2. So of the clock 1 takes place after 33 seconds. In next 33 seconds, strike 1 takes place. Right? Whereas in clock 2, in the next 22 seconds, right? Strike 2. That means at 12:22, strike 1, sorry, not strike 2. It is strike 1 takes place in clock 2. Whereas in clock 1, exactly at 12:33, right? So strike 2 takes place, right? Whereas strike 3 takes place after 33 seconds. That means 33 into 2 after this, right? Whereas strike 3 takes place in clock 2 after 22 into 2 seconds, right? Whereas fourth strike takes place after 33 into 3. Exactly at this point, strike 4 takes place, right? Strike 5, so fifth strike takes place at 33 into 4th second, right? Whereas the sixth strike takes place at 33 into fifth second, right? So sixth stroke, right? Sixth stroke of the first clock takes place at 33 into fifth second. That is 5 into 3, 15. So at 165th second. So sixth stroke takes place. Whereas in case of clock 2, so this is first stroke, second, third, fourth one, fifth one, sixth one. So there are 8 strokes, right? 7 and 8th one. So we'll continue that. 22 into 3 and fifth stroke. So at 22 into 4. So sixth stroke 22 into 5. 22 into 6 and 22 into 7th second at this second. So 8th stroke takes place, right? So it is 154th second. Here the question is, what is the interval between these two strokes? So interval between these two. So interval, time interval is equal to 165th second minus 154th second. So interval between these two strokes is 11 seconds, right? There is an interval of 11 seconds between these two strokes. Sixth stroke of first clock and eighth stroke of second clock, right? Here, second clock, eighth stroke of second clock strikes first. So, which is at 154th second. After that, sixth stroke of first clock take place, right? Therefore, here the question is, what is the time interval between these two strokes? So it is 11 seconds. Option C is the right answer. Question number 40. One of the following is a day which cannot be the last day of the century. That day is. So here, last day of a century, so need not be a century. It may be 1 year, right? Its last day depends on how many weeks it has, how many weeks that particular year has, and how many odd days. So apart from that particular whole weeks, how many extra days the year has. Depending upon that, the last day, so which day is the last day of that year, it depends, right? So the whole concept depends on the concept of Gregorian calendar, right? So according to that Gregorian calendar, 1st January of Anno Domini 1 AD 1, 1st January of AD 1 was on Monday, right? First day of AD, Anno Domini 1 was on Monday, right? So here we'll consider 1 century, right? How many number of days a century has and how many extra days it has, right? So depending upon that, we can predict the last day of the century, right? So we'll consider first 100 years. Before going to 100 years, so if you consider AD1 this year, right? If first day is Monday, what will be the last day, right? So in first year, so we'll have 365 days, for example, right? 365 days means 52 weeks plus 1 day, 1 extra day, right? So the last day of 52nd week is Sunday. If first day is Monday, last day will be Sunday, right? So that it completes a week, right? If last but 1 day was Sunday, what is that extra day? It is again Monday. Last day is Monday, right? So last day of any year, it can be a Monday, right? Therefore, in 100 years, how many extra days we have? Adding up to all these extra years, how many odd days or extra days we have, right? So in the next year, in the second year, also we have 365 days, so which is 1 extra day. Whereas in the third year, we have 365 days, so our number of extra days are 1, right? Whereas in the fourth year, we have 364 days, right? There we have 2 extra days. Along with 52 weeks, we have 2 extra days, right? So in this manner, if we add up to 100 years, first year, second year, third year, up to 100 years, right? So adding up all these odd days or extra days, we will have 3 extra days or 3 odd days in 100 years, right? So in 100 years, so we'll have 3 odd days. These odd days are, first odd day will be Monday, right? Because so it makes so many weeks, 100 years makes so many, or so many weeks make 100 years, right? So along with so many weeks, we have 3 odd days, right? So a week complete, last day of the week is Sunday, according to the concept here, Anno Domini concept, right? So after the last week, first odd day will be Monday, right? So odd day can be a Monday, right? So second odd day will be Tuesday. Third odd day will be Wednesday. This Wednesday is last day of the century, right? Therefore, last 3 days are, in first 100 years, last 3 days are Monday, Tuesday and Wednesday. Wednesday is the last day, right? If you consider one more century, so in the next 200 years, right? Next 200 years, we will have, according to the same concept, if you continue, right, adding these extra days, you will have 5 odd days by the end of 200 years. These 5 odd days are starting from Monday, Tuesday, Wednesday, Thursday, and Friday. Therefore, here Friday is last day of the second century, whereas Wednesday is last day of first century, right? So we'll consider one more century. So in the next 100 years, we will have only one odd day, right? One odd day by the end of third century, right? That odd day is Monday, right? So this is the last day of third century, right? So last day can be Monday, Friday, or Wednesday. So in the next 100 years, by the end of fourth century, so we don't have any odd days, 0 odd days, right? 0 odd days. Therefore, there will not be, that means the last day will be obviously Sunday. Last day, because it completes the weeks, right? Last day will be last day of the week, which is a Sunday, right? Therefore, last days can be in a century, last days can be Wednesday, Friday, Monday, or Sunday, right? Therefore, so we'll delete this. Last days can be Wednesday, Friday, Monday, or Sunday. Therefore, last days of a century, right, cannot be, not last days of a year, right? Last day of a year. Last days of a century cannot be the remaining days, right? It cannot be Tuesday, it cannot be Thursday, it cannot be Saturday, right? Therefore, so according to the given option, so the day which cannot be the last day of the century is a Tuesday, right? So Sunday can be the last day, Monday can be a last day, or Friday can be a last day. So according to the concept which I have explained just now, so last day cannot be a Tuesday, right? Hence option C is the right answer. Students, with this I am completing this paper. If you want to practice all the questions, please visit our website www.examsnet.com. You can also download our app. The link is given in the description box. I wish you a very best of luck for your future exams.